Hey, good afternoon. Good afternoon, everyone. I have two people here, right? I have two
How
people.
you doing, Professor? Good
Good.
afternoon.
How are you, Peter? Why you have something like, for your profile picture, why you have something like a mugshot?
Yeah, it was an old photo from like a long time ago. It's the only photo I had on my computer. It's crazy.
My crazy life, huh? All righty. Yeah, how are you, Jamming?
I'm good,
Jamming, are you
Professor.
there? Yeah,
I'm
how
good.
are you? How
I'm
are
good.
you? Let's see. Uh, s- am I sharing my screen? No, maybe not. So let me share my screen. And why? It's a kind of disaster. We have only two people. Um, I have a good news and bad news. Good news is that I have my computer back. The bad news is, they couldn't recover any data. So, but most of my data were backed up in the cloud and also in my external hard drive. About 95% were recovered, but that 5%, these were the files that I most recently created, and they are gone. And somehow I need those files. But it's not, it's not that, critical. It's not like a matter of life or death. Um, but still, so that's the bad news. Good news, and then I was able to reinstall most of the apps that I use. Still some are missing. So still, that gives me some limitations in the range of actions that I can take. But it's still better than nothing. And now I have Windows 11 on this computer. I used to have Windows 10. Windows 10 is still new. Windows 11 just came out this September, so it's super new. And the temporary computer I used, it was running on Windows 7. So how it was very slow, very limited. But anyway, I have also the whiteboard back. And since I have whiteboard, that gives me a lot of room for, okay, something like this. So let me, so, so last class, right? And where's my file? Let me also, okay. So I'm also, I'm new to Windows 11, so I'm still getting my learning, and getting my way around, um, or learning my way around. So, in our last class, we were, okay, where is that? We were talking about the examples of the present value of annuities. Let me open uh, the examples, and we had two examples. One is, lottery, right? And the second one was, car finance. And I said lottery example. Lottery is a very impractical example, because in reality, how many of you win lottery? It's, even if you win lottery, it's just like once in a lifetime. It's not like every other month, or every year. So you might say, if lottery is not down to earth or close to life example, why? Although lottery per se is very unlikely example, very impractical and unlikely example, but the rationale behind it is quite pedagogical. In other words, and I've been telling you this over and over, in reality, all the loans are basically present value of annuities. Why? Think about it. If you took out a mortgage loan, 30-year mortgage loan, right? You will make monthly payments, right, for the next 360 months. And this is exactly like lottery. Think about it. If you won the lottery, you will be receiving this payment. But if you have mortgage, 30-year mortgage, you will be making this payment, right? So you just, turn the table around, and it's the same thing, right? There's no, I've been also telling you this over and over. There is no lender or no bank that will wait 30 years for you to come up with a full lump sum future value to pay back in a single lump sum, right? The payment starts already, right the next month. So the point is, the smaller scale example, as a smaller scale example, we talked about the car financing example, right? Remember that? The car financing example. Price of the car, 30K. And you are making a down payment of 6K. Yeah, in any, make the down payment. And then the loan is 24K, right? The loan is 24K. And you might be wondering, so do I need to go to the bank and get a loan, secure a loan, get a loan before I go to the dealership? No, you go to the car dealership, and the car dealerships have, they arrange the lender for you. And most automakers have their own bank. They have their own financing arm. So these banks basically, GM has their own financing arm, their own bank. Chrysler has their own bank. Ford has their own bank. Hyundai and Kia have their own bank. They are, all called, Hyundai Financing Service or something. So you made, 6,000 down payment, and the bank paid the rest, right? 24K. So the dealership got paid 30K. So you drive out in a new car out of the dealership. And then the question is, there are, first of all, you might wonder, I have $30,000. Can I not just, pay 30,000 lump sum up front, without financing, yes, you can do that. Of course, you can do that. But then think about the opportunity cost. Now, if in this example, if the interest rate on your loan is 6% and term of the loan is 5 years, of course, the payment is monthly, so M is 12. That will make our periodic rate 0.5%. And our N, 60 months, of course. Then think about it. The question is, if I didn't finance it, but just paid full, full price at time zero, right, in lump sum, 30K, then that means you won't be having you won't be having 24K, right? If you financed, you would still have your own your 24K, and you can invest it in something. Invest in something that gives you 12% return on investment a year. 12%. Now then think about it. If you finance it for 24K, you'll be paying 6% interest a year, right? 6% interest. But with preserved 24K, the 24K that you preserved, right? You can invest it in something that pays 12% return. Then your own, this 12% is more than enough to pay for the interest, right? You will pay the interest and still have 6% left, right? In other words, your loan is basically, your loan is paid for, right, by your, by your investment, right? So this is why you would rather finance than pay outright, buy outright, right? Again, then think about it. These days, this is 6% is just an example. The reality is, the actual APR is even close to 1% at best, right? Of course, that's prevailing market rate. At the car dealerships, maybe, if you have a great credit score, you may get about 3%, right? Your interest rate may be about 3%. Still, then, if you have an investment opportunity that will give you 12% return, that 12% more than enough, right? It pays more than enough for right for the right, pays more than enough. So when the interest rate is low, right, it makes all the more sense to finance. I mean, think about it. That's what happens, when interest rate is low, there's clearly more borrowing, right? And that's the whole idea behind, the interest rate, right? So the next question, okay, so if you're clear about that, and our next question is, um, so you financed it and you leave the dealership in your new car, and then they say at the dealership, they said your monthly payment is $500. And in your mind, you just do a quick mental math. Okay, if it is 500, 60 months, for 60 months, it's going to be, 30K, 60 months. So since since the loan principal is 24K, 6K must be my interest. Oh, what a coincidence. I made 6K down payment and, exactly, 6K interest. That seems reasonable for 5 years, you might think. But then again, this is not the way it works. And since since you have learned finance, this is um, clearly wrong. And one thing you can also one thing you can easily tell is that uh, um, interest rate is 6% annually, but then um, the principal is 24K times 0.06 is 1,440 per year. And then, this is not right. I'm not saying this is, but, people who don't have um, finance training or economics training would easily think, oh, it's, 6% a year. This is 6% a year for 5 years, and it should be 7,020. So, oh, I'm actually getting a good deal. I'm not really paying, I'm really paying less than 6% a year. True, you should be paying less than 6% a year. I mean, less than what I'm saying is you shouldn't be, you're not paying 1,440 every year for 5 years. This is wrong. This is just uh, uh, the back of the envelope calculation by some untrained people, right? Because first of all, interest cannot be constantly, 1440. It cannot be 1440, right? Why? Because this is not a single cash flow model. I mean, you're not paying back in lump sum, and your principal is going down every month, month by month. Your principal is going down because you're making payment. So then the interest cannot be the same every year, right? Make sense? So how do we handle this? So in our last class, I think we were talking all the way up to this. So there are two ways we can approach this. Two ways. One, find the present value of all these annuity payments. Present value of all these annuities, right? In other words, present value of all these $500, right? Oh, why am I using the mouse? Okay, find the present value of sum, right? Sum of all these, present values of $500. And if this is the correct monthly payment, it should be equal to the principal, right? The principal is 24K. It must be equal to 24K, right? But if this is not the correct payment, the chances are this could be greater than the principal or less than the principal, right? It could be greater than the principal or less than the principal. right? Makes sense? So one way we can find the present values of all those annuity payments and compare it with the principal. And if that payment is correct, it must be equal. The second thing we can do is we can nail the exact payment. We can nail the exact payment. So how do we do that? So think about it. So this is something I was, showing you, I believe. First of all, what's the present value of annuity formula? What's it like? Present value of annuity formula is payment over R minus payment over R times 1 plus R raised to N. Okay, so what did I say all the time? What do I say all the time? I always tell you, no matter how complex, no matter how complicated the equation may look, the key to solving any equation is to identify z equals x times y structure. Okay, then if x is the unknown, right, what? X is the z divided by y. Okay, so then next thing, is it z equals x times y structure? No. This looks like z, but then this certainly doesn't look like x times y. Then what do? We can factor out the common factor. And what's the common factor? Common factor here is payment over R, right? So if you factor it out, this term, the first term will be 1, just 1. Second term will be 1 over 1 plus R to the N, right? This is N. Why not? Why is it something's not N? Okay. It will become X times Y structure, right? But I'm going to factor out only payment. Okay, I'm going to factor out only payment. Then the first term will be 1 over R, and the second minus, and the second term will be 1 over R times 1 plus R to the N. Okay? Now then, think about it. This way, we turned it into z equals x times y structure, right? We turned it into, and x happens to be exactly the payment, right? X happens to be the payment. So then if that's the case, now solving for x is easy, right? We simply divide, right? PVA, which is z, by the thing in the bracket. Now, before we do that, let's simplify the thing in the bracket a little more, because the thing in the bracket can have a unified denominator, right? Now, this denominator, one is R, the other one is R times 1 plus R to the N. So it's like this. It's like when we have, if we have, if we have 1 over 2 minus 1 over 6, what do? We unify or combine the denominators, right? Because 2 times 3 is 6, we'll need to multiply both 3 to both the numerator and denominator. So then this can be, both can be, now the denominator is unified, and then this one will have to be 3, but nothing to do to the second numerator, because the second fraction was already 1 over 6. Okay, this way we can come to 2 over 6, which is 1 over 3, right? So just like that, we do the same thing here. The second term is already r times 1 plus r to the n. So I multiply 1 plus r to the n to both top and bottom. So now the bottom, the denominator, will be unified. The top will be 1 plus r to the n, and then minus 1. Okay? Now, we can now divide, right? We can now do x equals z divided by y. So then solving this equation for payment, is present value of annuity divided by the thing in the bracket, And look, dividing by a fraction is the same thing as multiplying by the reciprocal of the fraction. Isn't it right? When you divide something by a fraction, it's the same thing as multiplying by the reciprocal. And we all know that the negative exponent is the reciprocal, right? So therefore, we only need to fill in the reciprocal of the thing in the bracket. And if you do that, that will be present value of annuities times r times 1 plus r to the n, and at the bottom it's going to be 1 plus r to the n minus 1. Okay? All right. So now we have the formula for payment and the present value of annuities. So then let's do this example now. You downloaded this file in the previous classes, and so you must have this file on your computer, right? You have these. So I want you to open and go to row 16. Go to row 16, right? Go to row 16. So you have this file in front of you. Ashley, do you have this file in front of you, Ashley?
Yes.
Yes.
Okay, great, good, good. Daxton, do you have this file in front of you, Daxton?
Yeah.
Okay, good, good. Edgar, do you have this file in front of you, Edgar? Edgar? Jamin, do you have this file in front of you?
I'm pulling it up right now.
Okay. Jose, Jorge, okay, good. Jorge, you have it. Mamadou, do you have this in front of you? Mamadou? Peter, do you have this file in front of you? Peter?
Yes, yes, yes.
Okay, good, good. Stacy, do you have it in front of you? Stacy? Zaid, do you have this file in front of you? Zaid? Okay, so I would have to assume that everyone is. So go to row 16 and A19 and A20, they must be deleted. They must be cleared out. So 17 and 18, that's our what, lottery example, lottery, right? So to find present value, so the first method is we want to find the present value of all these $500 and then compare it with the principal you owe, right? If it is not equal to the principal you owe, something's not right. Of course, we already know what is the periodic rate and what is n. I can just copy and drag it up. Okay, 0.5% and 60 months, and then using the present value of annuity formula, right? Payment over R minus payment over open parenthesis, one more, 1 plus R is to N, and is here, minus 1, close parenthesis. Okay? And if you have that formula in that cell, hit enter. Oh, something there. A16, E16 minus A16 plus over 1 R times. I forgot. I'm sorry. I forgot R times. Forgot R times. Okay, and hit enter. Why? Something's not right. This cannot be. Payment over R minus payment over R times 1 plus R raised to N minus 1. Something's not right. Oh, not minus. What did I do? Why minus 1? So, okay. There you go. All right, we got the present value of those annuities. Present value of those annuities. And then what is our conclusion? It must be equal to the principal of 24K, right? But it's not. It's more than 24K. So that means we are paying more than what we owe. We're paying more than what we owe. And some of you may say, isn't it only natural? I mean, shouldn't we be paying more than what we owe because we have interest? Yes, you're right. But the interest is already built into these payments. Interest is already built into these payments. The payment is basically comprised of principal and interest. So over the next 60 months, every payment includes interest. And this is not the total amount of this is not the total amount of what you pay. This is not the sum of these. This is the present value, sum of all the present values. So sum of all the present values must be equal to the principal, right? Otherwise, you're really over. Otherwise, something's wrong. And here, so we got it. So you're being ripped off. Okay. Let's also verify that one more time by nailing the exact payment. Nailing the exact payment. Now, to find the exact payment, right, we'll have to set the present value of annuities equal to the principal. So why? Because the correct payment, the present value of the correct payment, all, present value of all the correct payments must be equal to the principal, right? And then, given all that, we will exactly enter the formula, which is PVA times R times 1 plus R to the n, right? R times 1 plus R raised to n. Okay? Divided by, what did I do? R is here, right? And divided by, open parenthesis, open another one, 1 plus R, again, 1 plus R raised to n minus 1. Okay? Okay? Compare that with the phone. Yeah? And you might wonder, oh, there's a big bracket outside, shouldn't we put that big bracket there? No, you don't have to. Why? Because when you are multiplying something fraction, anyway, that will be multiplied only to the numerator. So for numerator, we don't need. We only need a bracket for actually, for the denominator, right? But it doesn't do any harm when you put a big, it doesn't do any harm when you put a big outer bracket around both, numerator and the denominator, right? In other words, around the entire fraction. So if you did that, if you built that formula into your cell, hit enter, and voila. So what did you get? You should get, this is the number you should get, which is, almost, which is 464, almost 464. So what does that mean? This also points to the same thing. You're being ripped off. It also points to the same thing. You're being ripped off, right? By about $36 every month. Okay? So everyone is good. Everyone is okay up to this point. Everyone. Any questions so far? All right. If you don't have any more questions, then we're going to move on to the amortization. And what is amortization? The word amortization means, paying down the debt. So, but, let's think about the radical, the etymology, the radical, what do you, okay, amortize. Amortize. What is the radical of the word? I mean, this means, pay down the debt, but where is the what is the radical of the word? Does anyone have any idea? What is the radical of the word? Radical. This radical doesn't mean radical, extremist. Radical. Huh?
Radical of the what?
Radical of this word. What is the radical of this word?
I can't even understand that handwriting.
Amortize.
Amortize.
Amortize. Okay. Radical means root of the word, right? So
how do you find the root of a word? I thought you could only find the root of a number.
Yeah, root, root. All the words come from somewhere, right? All the words come from somewhere. Hmm? Don't you think? All the words come from somewhere. The root of the word amortize is this, mort. And does it ring any bell? Does it ring any bell? Hmm?
I don't know how you found that. It looks kind of random to me.
Random? Why is it random? Haven't you heard of the word mortality, mortician,
Oh yeah,
mortuary,
yeah,
mortal?
yeah. I've heard of all those words.
So what does that mean? Huh?
Yeah,
You know?
I, mean, I heard of it, but like I never knew it was called finding the radical of a word. I never knew that.
Yeah, radical means the root of the word. Radical of the word means the root of the word. That's the root. And then, of course, it comes from Latin, right? And also the Latin root. It has uh, a lot of words, a lot of English words come from, has Latin root, right? Almost everything. Annuity, even, right? Present, value, all of those words come from Latin. Um, and the word mort, that means death. And in French, this is, French mort. That means dead. Il est mort. He's dead. Huh? Now, then why is the word death in there? Uh, it means, first of all, it means death of the debt. You are bringing death to the debt, right? Death, your debt comes to death. So, how come, that means paying down? How come does that mean pay down? Of course, it means pay down because let's take a look at this picture. This picture is showing you, this picture is showing you um, basically, look at the timeline, 2010 through 2040. So 30 year. 30 year, let's say something like 30-year mortgage. And then what are those vertical bars? Those vertical bars represent monthly payment. And the monthly payment is almost like $700. 700. There will be 360 of them. There will be 360 of these, monthly payments. Of course, monthly payment is comprised of interest and principal, and it's not in equal proportion. You might think, if you're making $700 monthly payment, that must be, every month, the same. It will be always in same proportion, like, $500 principal and $200 interest. No, it's not like that. So you might wonder, why is that vertical bar partially yellow and partially green? The green is the principal, right? Portion of the principal. Yellow is the interest. So think about it. If your monthly payment is 700, so every month it's the same height because every month is 700, right? Makes sense? Every month 700. But early on, it means it's mostly interest, right? And as time goes by, as time goes on, uh, interest portion gets smaller and smaller and smaller, and the principal gets bigger and bigger and bigger, right? In other words, principal paid, portion of the principal paid gets bigger and bigger and bigger. So then what will the balance, what will the principal balance look like? The principal balance will look like this red curve. It will look like a red curve. At first, so what should be the principal balance at the beginning? At time zero, the principal balance must be something like, from my calculation, it would be, if monthly it's 700, right? And if we find the present value of all those annuities for 360 months, let's just, do a rough, so we enter 700 here. And for 30 years, yeah, the present value of annuities must be something like $116,000, 116,000, right? So that is the principal, and then the principal will decrease. The principal will decrease little by little as your principal payment is growing, right? More and more as time goes on. So the principal balance should go down like this. But then you might wonder, if that is the principal balance, then we just calculated at time zero, it is $116,000. How can it be the same height? No, it's not the same height. It's actually like this. We are combining putting two different graphs into one. Okay, so what I'm talking about is one graph is the graph of the principal balance. I can do it with hand. Okay. Oops. What? One graph is the why? One graph is the graph of the principal balance. So the principal balance, of course, that's dollar value, and the vertical axis is dollar value. Horizontal axis is time. Okay. Come on. So we'll have and then let's say this is 116K, and each notch represents like 10K. Each notch represents 10K. So over a 30-year period, it will decline or decay like this, right? And the other graph, of course, then the other graph will be the graph of the other graph will be the payment. Other graph will be the graph of the payment. It's also dollars. Okay. But and the vertical horizontal axis is time, and then each notch is, in this case, 100. 100, 200, 3, 4, 5, 6, 700, right? So, and then it is horizontal. Every time, every month is the same. Now, suppose, so this level is 700. Suppose you're putting these two graphs into one. If you're putting these two graphs into one, how would you do that? I mean, if you are, because this one, for this one, each notch is 10K. I mean, if we put it on the same axis, then the payments will be crawling at the bottom through and through. So instead, what they do is, when you combine two graphs, we will use two vertical axes. two vertical axes, right? Left vertical axis, it's principal balance and in dollars, right? And then everything is like, you know, here, every notch is 10K. On the right vertical axis, payment, and then 1, 2, 3, 4, 5, 6. Each notch is just, you know, $100, right? Makes sense? $100. And then we can combine these two graphs, right? You know, principal balance will look like that, and then the payment will look like this. Okay, makes sense? Now, and then this pattern of the curve is called the decaying pattern. This is decaying. When something decays, you know, early on, right? It decays at a slower rate, and the rate gets faster and faster, right? So the slope of the curve is flat early on, but the slope gets steeper as time goes on. That's called decay, right? And then think about it. Decay means, you know, at the end of decay, it dies. So think about it. This is showing you the principal is decaying and eventually dying. It doesn't go below this, but, you know, it stops here. It dies when it reaches zero, right? That's why it's called amortization, right? And through monthly payments, you're slowly decaying your debt, right? Your principal balance is decreasing gradually. So that's why it is called amortization. And then, so let's do this example. Let's build the amortization schedule. An amortization schedule is basically, you know, row 28. From row 28, that's where it starts. And to do that example, let me. So amortization schedule basically shows how the interest, how the payment breaks down into interest and principal, right? And it shows principal balance each time. So to do this, I want you to make I want you to make the first row, row 22. I mean, row 22 should be the top row, right? Because we need more, you know, viewable area. And then select B29. And once you select B29, go to the view and go to freeze pane and click freeze pane. And once you did that, you see these, you know, vertical line and, you know, horizontal line is, you know, formed there. It's put there. And then as you scroll down, if you scroll down, you won't lose sight of the label. Okay, and you won't lose sight of the original data, the reference data that we need to use. And as you scroll to the right, you won't lose the sight of the first row. Okay, first column, right? First column. Okay, then first, payment. We all know that the payment is this 823, right? And through, every month is still, 823. It should still, it should be locked into 823. Otherwise, when we drag it down, because it's the same amount every month, so I want to copy it down, copy and paste it down. But then if I do it without locking into 823, then it's going to change as I go down. So I'm going to lock it by, you know how to lock it, hit F4, right? Hit F4. Okay. On some computers, on some keyboards, you will have to hit both function key and F4 key. Function and F4 together. And then I can copy and drag it down. I can drag it down all the way down until you see payment 60, right? Payment number 60. And it's all for, every month is still the same thing. And I already encoded, I already encoded there sum. So it's going to give me the sum of all those, monthly payments. Total. So your total payment is this. Now, interest, we all know every month the interest rate is this, isn't it right? Every month. So we're going to lock it too, because it's going to be repeated over and over. It's going to be, right? And we pay interest of 0.5% on what? In the first month, at time zero, we all know we pay interest on the principal, isn't that right? We pay interest on the principal, right? And then at time zero, right? At time zero, in the first month, what is the principal that we have? What is the principal we are facing? What is the principal we are confronted with? At time zero. Anyone? I have 8 people. I have 8 people.
0. You said time. You said something times 0. So would it just be 0?
At time zero. At time zero. In other words, time zero. Time zero is the beginning of this timeline, right? Beginning of this timeline. So beginning of first month. At time zero, what is the principal that we are facing?
Whoa, I don't know.
Well, we pay interest on the principal, isn't that right?
Yeah.
So at time zero, what is the principal?
You're paying interest? I don't know. Since it's like 0, wouldn't it just be 0?
What is 0?
There's no.
Why 0?
Because you're not paying anything yet. Because it's 0.
What do you mean? Yeah. At time zero, you're not paying anything, but you will make the payment at the end of the first month. Yeah. So, let's say the interest that you're paying will be at time 1, right? But what is the principal that this interest is applying to? What is the principal this interest rate is applying to?
The first month?
Yeah, in the first month, what is the principal that this interest rate is applying to?
The first payment, right?
Yeah. So to calculate the interest payment, right, we must multiply the interest rate to the principal. So what is the principal
times the
that we are facing at time 0?
I don't know. I don't know.
Well, just think logically. I mean, we have a loan, right?
What's the
So
interest rate
in the
you're
first,
paying at month 0?
say that again.
I'm trying to think about the interest rate I'm paying at month 0. That's what you said, right?
No, month there is no such thing as month 0. it's month one. But the beginning of month one is time 0, isn't that right?
Yeah.
Just like, the beginning of today is 0 hour, 0 hour, right?
Yeah.
And only at the end of today, then we completed day 1, right?
Yes.
So in the first month, what is the principle that we are facing? We'll pay 0.5% on that principal. So, and every month we'll pay 0.5% on the principal balance. I mean, but at time 0, what is the principal?
Is that because the rate, it says 50, it's 0.50%? Is that why?
Yeah, that's the rate. That's just the interest rate. That is not the principal. It's the interest rate.
Per month?
Yeah, per month, of course.
Okay, so then whatever you have to, whatever the payment is, would you just multiply it by the interest rate per month is 0.50?
No, 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 no. Payment is not the principal. Payment is not the principal. Think about it. Principal is what?
I don't see it on your chart, right? Labeled anywhere.
It is. It is. It's right in your eyes.
$463.
No, 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 no. That 463 is payment. Payment is not the principal.
I don't know. I'm not seeing it.
What do you mean it's not there? I mean, think logically. I mean, think about it. You bought a car. You bought a car, but you made a down payment of 6K, and then the rest was financed. The price of the car was 30K. The rest was financed. That means the rest from 30K, the price of the car, value of the car, since you made 6K, down payment of 6K, the difference is the loan amount.
Oh, so
Isn't that right?
wait, the principal is just the total minus the down payment, and then whatever's left is the principal. Is that what
Yeah,
you're
yeah,
saying?
yeah, yeah. So what is the principal?
Um, well, after you make your payment and after you pay the
No, no,
interest.
no, no. Before, I mean, you have to calculate the interest first. So you have to know your principal before making the payment, before making the interest payment and principal payment. Oh,
So what's the total? So I can know I'm paying.
look, I said price of the car was 30K. I mean, this was something we have already. This was something we have already all this time, right?
Yeah.
You're buying a car. The price of the car is 30K with 20% down, right?
Yeah.
What were you looking? Um,
So
Here,
what's
price of the
20?
car is 30K.
Yes, the
Down
loan I
payment
just
6K. Loan is 24K.
so the principal is the 24K then?
Yeah, yes, of course. That's the principle,
Okay.
right? It's just
Yeah.
logical, I mean, you can follow. Look, then the principle is right here, isn't it right?
I was thinking that, but then I didn't want to say it because I was like,
What
I
do you
was
mean?
afraid of
Why
it.
don't you want to? And some
I was
people
gonna.
were saying, it's not there. I don't see it. Well, it was right in your face. And logically, think about it. Logically, that's the money borrowed. So that's the principal, right? So then you will pay 0.5% of the principal in the first month. That will be $120. Then what will be the principal paid?
Principal pay.
What will be the principal paid? It's just the logic. Give me the logic.
would it just be those two? You just add those two up?
And add those two. What are those two?
Add the payment and the interest.
No, 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 no. Look, this is the payment, monthly payment. And please, think logically. If this is the monthly payment breaks down into Didn't I say monthly payment is comprised of interest and principal?
Oh yeah, you did say it. Oh, so just 463 minus.
You don't need to give the number. You'll just give me the logic. Huh?
Well, subtract the payment, and you subtract the interest payment from the
Right.
payment.
Right. You subtract the interest paid from the payment,
Yeah.
right? And that's the principal paid. And then, so at the end of the first month, what should be the principal balance now?
What is that? Is that equal to everything?
What do you mean equal to everything?
How would I find that? Like you told me before, I had to find the principal by subtracting those two. So how would I find this one?
So you tell me how to find this one. And if you just follow the logic, you should easily know.
You would take away the principal paid from the principal balance, and you get like 23,656 in a penny.
Yeah. Don't give me the numbers. Just give me the logic. Give me the logic. I think you got that. So what do you do here?
Principal take away principal paid.
Yeah. You mean this 20 PVA, which is the original principal, right? Right. Because the original principal was this, and it goes down by as much as this. Isn't it right?
Yeah.
Yes.
And who was that? Who gave me that answer?
Peter.
Yeah. Okay, Peter Moore, right? Peter. Okay, Peter. So I'll give you 0.25. Now, so in the second month, so I will just copy and paste the first month, but this is wrong. We'll need to make some adjustment. Why? Let's see. In the second month, interest rate is 0.5%, but it's pointing to G24. There is no G24. I mean, you will see right after row 23, then it jumps to row 27 because I truncated, I collapsed those, rows 24 through 26 because there's nothing. Okay, so G24 is actually pointing to nothing. So actually what this should be pointing to should be, now in the second month, what is the principal now in the second month? What is the principal in the second month? Oh, no one gets this? Look, this is the principal in the first month. In the second month, principal is this. Isn't it right? Principal went down from the original principal. It went down by as much as this. So in the second month, the principal you're facing is this. Does that make sense? Anyone? I'm showing me some vital sign.
Question. I thought my mic was on the whole time. Question, Professor. When you have the collapse row, right, for number 2, you said that it won't show you the row 28 because you collapsed it, right?
No. It doesn't show row 24 through row 26 because I collapsed those rows because there's nothing there.
All right. So
right? And then in the second month, this is the new principal you are facing. That's why it's called principal balance. Originally, this was the principal originally. This was the principal originally, but that was in month 1. And at the end of the month 1, principal went down by as much as this. So this is the new principal at the beginning of second month, right? So you will have to make it point to this, right? And then this is nothing nothing to touch here because that's the logic, I mean, principal balance would have to be like that. And then here, then at the end of the second month, the principal balance should go down, not from G24. There's nothing in G24 because there's no such row as G24. It's just, because I dragged it down from G23, it just automatically becomes G24, but there's nothing. So you need to make an adjustment. Principal balance will go down by this much from this. Isn't that right?
All right, so I think I'm having confusion on the interest paid for the next month because when I don't get 118.28. That's where I'm having confusion at.
Why? Did you do this? Did you do it exactly like this?
When I do the $, maybe it's because I'm on numbers, but when I do the $E, $23, it actually like cuts off the formula and it won't allow me to get E29 as well with the multiplication. So it comes out to like 210 or something. It comes out a little bit more overstated.
Did you okay, was it, did you do this like this, or did you just enter manually? Did you just input 0.5? Did you do it like this?
1 second, I have 0.5, that's why. Okay.
Yeah,
Now
0.5%.
B23,
But manually or what?
B23 by D23. Okay, now I have the right thing.
Once this is
for the
fixed,
rate
this
I
goes.
had, I'm sorry, Professor. For the rate I had 0.50, I didn't have the formula, so that's why it was coming out that way.
So I've been telling you, you don't enter manually anything unless it is the initial data, right? Unless it is the initial data, you don't put manual. So once you are done up to this point, then it's home free. You're home free. It's a walk through the park. All you need to do is highlight those 3 cells and drag it down. Drag it down all the way to month 60, right? And then you can tell whether you got it right or wrong because column D is what? Principal paid, and then this cell is the sum of that column, right? It's the sum of the column. So if you have by month 60, you will have paid off your principal. So sum of all that column must be 24K, and it's exactly 24K. Isn't that right? So and another thing is principal balance. By the end of month 60, your principal balance must be 0 because you have paid it off, right? Since you have paid it off, it should be 0. So it's 0. And
right.
then column C, column C is the interest. So sum of all that interest, sum of that column is that. And then if you add these two, that number must be the sum of all the payments. And this is the sum of all the payments. And that's exactly, if you add these two, that's exactly equal to this. So we're good. It all checks out. It all checked out, and we are impeccably right, and we are immaculate and impeccable in this amortization schedule. Principal balance is 0. So what does this show? It's exactly the picture like this, right? Your principal balance is dropping like this, decaying in a decaying pattern, and then your monthly payments even all the time, but your monthly the composition of interest and principal paid will look like this, because the more principal is paid, then principal balance drops like this, and as the principal balance drops, interest gets smaller, and then because principal is dropping, interest gets smaller, and then the rest of the payment, which is the principal paid, will have to get bigger, right? Then this way, we can, as I said, we can amortization schedule can help us in two ways. One, it breaks down month by month. It breaks down the payment into interest and principal, and then it tells you what is the principal balance after that month. So suppose you made payment up to month 12, and the principal balance then you came by a large sum of money. You came by a large sum of money, and you're you're tired of making monthly payments, and you just want to pay it off. And then you know how much is left. You know your payoff amount. This is the payoff amount exactly, because that's the principal left, right? Principal balance. And actual payoff amount will be slightly different because they will have some administrative fees and transaction cost, but that won't be more than $30. That won't be more than $30, right? So we will pretty much know how much we have left, right, in principal balance. Okay, and you see this can be done. I mean, we have 60-month amortization schedule now, but we can do the same thing for like 30-year mortgage, the 360 months. And you can once you get the hang of it, you can do this in just once you get the hang of it, it won't take more than 30 seconds.
Hey, Professor, this is
Yeah.
sort of an unrelated question. I came in a little late to class. You might have already discussed it, but the quiz that was, I think, due on Saturday or something. It was due this Sunday. It was due. I mean, Sunday, not this Sunday, last Sunday. Sunday. So that was 21st, I believe. Sunday was 21st. Yeah, but I think I did it on the right time, but it said it was late or something. I did it at the right time.
Yeah. Send me an email to remind me, so I will look into that. Okay, I will look into it. But whatever the cutoff time, it's the McGraw-Hill server. It will clock it exactly at that.
We have like one more quiz left, right? And these quizzes, these four.
Final, only final left. Only final.
They count for like a lot, right? Like pretty much the whole.
It's 25%. 25%. That's 25. Midterm was 25. Final 25. Quiz 120. Quiz 220. Okay.
Okay.
Alrighty. So we're out of time. So if you don't have any more questions, then we'll call it a day. And think about what a lasting impression.
Sorry. One last question.
What a lasting impression you can make. For example, if you are at a job interview and if you can display this technique and just build amortization schedule in 30 seconds for 30-year mortgage, you display this, it will definitely have an impact on the on your employment. Yeah.
Where do I go to fill out the vaccine form thingy that you were saying that we need for this class?
I don't know. I mean, BMCC, consult the BMCC website, because I only reproduced the message that came from the provost office, right?
I want to do it before the end of this class, because you remember.
Yeah.
Where do I do it though? I don't know where to go. I've been on the Blackboard site and I can't.
Well, look. As I said, go to the. You need to go to the BMCC website, and there will be a lot of links about COVID-19, something vaccination, something.
All right.
Right? And wasn't in one of my announcements, it could have been, look, it's really, I'm already 9 minutes past the so I will today is the last before Thanksgiving, last day, because we don't have any Thursday. So I will see you guys on November 30th, which is Tuesday.
All right.
Okay. All right.
Have a great afternoon and great
God bless
Thanksgiving.
everyone.
All righty. Take care. Now I'll stop sharing, stop recording.